Welcome students, I am Delphin Raj, Assistant Professor, Department of Mechanical Engineering. Our subject is Engineering Graphics and our subject code is GE8152. First, you must know what you mean by engineering graphics and what is the need for the study of engineering graphics. Engineering graphics is nothing but a language of an engineer. It has been said it is a language, it's a graphical language. That means it consists of a lot of drawings and shapes and dimension. Okay, it is effective communications among the engineers, something like that. There is a say. And think about the language. For what purpose we use the language? Yes, to communicate or to share our feeling or to share our knowledge to someone, we use the language, right? The same manner in the engineering field, engineers are using the language, which is a graphical language that is known as engineering graphics. In order to communicate their idea to someone, they are using this as a medium. Okay, and then why we need to learn this subject? Some will say this subject is only meant for mechanical engineers or only for civil engineers, not for all the other branches. Not like that. Each and every engineer should know the knowledge of what? This engineering graphics. Depends irrespective of the departments. Each and every one should know it, because its importance is it will help us to plan the work and to work the plan, right? So it is very essential study for each and every engineers. If I talk about the application respective to the departments for mechanical field, I can say they will be having lot of machinery elements, right? When they are conveying their ideas regarding the machinery parts and machinery things, they will be using this effective graphical communication called graphics. If you see the civil department, they also having lot of construction like building blocks and then bridges, something like that. They also use the graphical language for their conveying their ideas. Okay, if you see the EEE department, EEE also having their own applications, something like they will be having lot of wirings and circuits, something like that. If you see the AC department, they are also having their own applications, like I can say they have the circuit boards, they have the networking, so there as well it uses. Okay, and then in the field of CSE as well IT, also they are having the applications, something like that. They also study the hardware related things as well, networking, something like that. There as well the graphical communication is needed. Okay, and here I will show you what are the drafting instruments, that means drafting tools are there in order to draw the drawing or to draft the work. Drawing instruments: drawing board, drawing sheet, set square, protractor, mini drafter, compass, divider, pencils, scale, pencil sharpener, eraser, etc., and French curve. Then let me get the knowledge of drawing sheet. Drawing sheet is a medium on which drawings are prepared by means of pencil or by means of pen. In the market, the drawing sheet available are A0, A1, A2, A3 and A4. In general, I can say the A1 sized paper is just of the size of the A0, and A2 sized paper is of the size of A1, and this A3 sized paper just of the size of A2, and this A4 sheet paper is just an of the size of A3. And about the dimensions for all the sized paper I have displayed here. In the engineering graphics, I recommend is to draw in the A3 sheet paper. And as far as the exam concerned, you have to draw using the A3 sheet paper. So I recommend to draw A3. Okay, its size is 297 into 420. Next we shall know about drawing board. So drawing board is usually made from the wooden materials, soft wooden materials. Okay, I recommend the paper as A3 and here the drawing board is D3. Okay, always remember the drawing board should be somewhat higher in dimension when compared with the paper size. Okay, so that's why here for D3 the dimension is given 500 cross 500. Okay, then set square. There are two forms of set square generally used. One is 45 degree 90 degree set square and another one is 30 degree 60 degree or 90 degree set square. Okay, and with the help of scale and set square the inclined line also can be drawn. Protractor. Protractor is actually is to measure or setting off an angles which cannot be obtained with set square. And this protractor is flat and semicircular in shape. The end, that means the circumferential end which reads 0 degree to 180 degree and which is readable from both ends. And next one is mini drafter. Drafter is actually a small drafting machine. This is a device used to draw parallel or inclined lines very effectively with a very easy manner. Okay, and when the drafter is clamped in the drawing board, remember one end is clamped by means of screw and another end is free in the drawing board which is adjustable. Okay, and it has a scale with 90 degree and also protractor which can be rotated at any degree. Compass. The compass is used to draw arc or circle. We know about the compass. One end of the leg of the compass will be needle point and next one leg will be to insert the pencil. Divider are used to transfer length to the drawings either from the scales or from the drawing itself. See, we don't want to take the repeated measurement again and again from the scale. By the help of this divider, we can take the reference from the drawing itself and we can proceed with it. And next is a pencil. And in the technical drawing, the pencil also one of the important tool to draw the technical drawings. Okay, and in the drawings you can see three kind of pencil, HP, H and 2H. Especially this HP is to draw the freehand sketch and object line. Okay, and this H pencil is to write the titles, notes, etc. And this 2H is specially we used to draw the construction line and the hidden line, right? And then pencil sharpener and eraser. Eraser we know to remove the unwanted element from the drawings and pencil sharpeners is to sharpen the lead of your pencil, right? Then French curve. This is an important one. Sometimes you may come across the difficult curve in your drawing, so just difficult curves. Okay, so it will be challenging for us to draw with freehand. At that time you can use just like this templates and you can bring your shape, right? So in order to draw the complicated shapes or curves in the drawing, you can make use of this French curve. It helps us to draw the complicated shapes. Okay, with the help of this template you can make it possible. And next, the important features in the engineering drawing is lines, dimensioning and lettering. Let me first concentrate on the lines. If you see the technical drawing, you may come across with a lot of different kind of lines, especially if you see continuous thick line like this manner, continuous thick line, it should be a dark line. It is especially done for object line or else visible line. Okay, then continuous thin line, if you see a line like this, it is specially meant for construction line and dimension line, extension line and leader lines. And dashed thick line, okay, you may see this kind of dashed lines, it is specially done for hidden line. Okay, the things or else edges which all are hidden from the current view will be capturing as a dash line, that is a hidden lines. Okay, then chain line, chain thin line, okay, that is a long line dot, long line dot. Okay, this is specially done for center lines. And next is dimensioning. In the technical drawing, this dimensioning is done to indicating the size and other details of the object essential for its construction and function on a drawing using lines, numerals, symbols, nodes, etc. is called dimensioning. If you come across these kind of drawings, you need to specify the length of the object, you need to specify the height of the object. If you have a square hole, something like this, you need to specify its measurements, something like that. Okay, next is types of dimensioning. One is chain dimensioning and next one is a parallel dimensioning. In the chain dimensioning, all the lines are taken, extension lines are taken, and the dimension line is drawn in a single stretch, and over the line the measurements are captured, right? If you see the parallel dimensioning, for each segment the extension line is dropped independently and the dimensioning line are given independent manner, something like this. So you can see the chain dimension how it is captured, and in the parallel dimensioning how it is captured. Both the methods we can implement in the drawing, no issues at all. Now I will demonstrate you how to draw the dimensions. First of all, you must draw the extension line. This is the given object for us. This dimension, that means the length of the object, I going to capture it first. So first of all, you need to draw the extension line. That line should be drawn perpendicular to the length. Okay, for the line I have taken the extension line. For the line I have taken the extension line perpendicular it. Okay, the same likewise all the other things, for detailing all the other things in the diagram, you have to take the extension line like this. Okay, it coming like this, and after completing the extension line, just take the dimension line. So first of all, see, I going to draw the dimension line for this length. Okay, so for that we have to take the dimension line, that means the filled arrows at the end, and this line should be parallel to the line to be dimension, right, for which I have drawn a parallel line. Okay, the same likewise we can do it for the rest of the dimensions. Okay, fine. And see, in order to denote the angle, I have taken this, I going to show the angle, so that I have taken the extension line like this manner and I have denoted as this manner. Okay, and after that how to denote the measurement above the line. Always how to denote your measurement above the line. Okay, say above the dimension line like this. Okay, fine. And remember, this dimension line should capture at the both ends with the filled arrows, and it should be 1:3 ratio. This arrow ratio should be 1:3, right? Its width, if the width of this arrow is 1, its length should be 3. Fine, right? And next is a leader line. Okay, leader line, that means here we have a circle, right, for which we can give a leader line. Let's see how I am making. So in order to note the circle as well the or, I have taken a leader line as this manner, and afterwards, so I am going to denote a diameter for this circle, so I have written D10, okay, D10 and comma 2 holes, which represent, in this diagram we have the 2 holes, which are these 2 holes are identical one. So we need not to represent the same measurement again and again. So if we are having 2 measurement or 2 holes for a diagram, you can capture like this: the same measurement distance D10 and comma right 2 holes. It says both the holes are identical one, right? And next, the arc is with the radius 16. So I have taken the leader line as this manner, and I have written above the leader line or 16. And next feature is lettering. Lettering is used for writing titles, subtitles, dimensions, scales, and other details on a drawing. And in the lettering, you must follow the rules. That means if you're writing any details, you want to draw a guidelines. Okay, if you are going to draw a note, write a note, you have to draw a guideline like this. For example, I have given here, okay, you have to draw a guidelines with a gap 5 mm, right? And here I have written engineering graphics is a universal language of engineers, right? So here I have taken a one line and coming to the next line, okay, it is a same sentence which is coming to the next line, for which I have added the space between the two line 1.5 mm. It is a rules, okay. If you are capturing the note, it should be 5 mm thickness, okay, for which you have to make the guidelines. And if it is exceeding the one line, the next line spacing should be maintained at 1.5. You can see here, right? Fine. And then you should not use any kind of stylish word. Just a stroke letter is more than enough, okay. Stylish words are prohibited here in the engineering graphics, and the letters should be very legible, okay. Fine. Examples of common mistake in lettering I have shown in this slide. The lettering style not uniform, that means sometimes you may draw the guidelines, and afterwards you may take the capital letter, and without your knowledge you may make a small letter too, right? So these kind of mistakes you should not do, right? Only you have to write with a capital letter. Lettering height should be uniform. These kind of things should not happen in your writings, okay. Lettering size should be uniform. Lettering inclination not uniform, okay. So you should not make such inclination. Just try to go with the a stroke letter. It should be the line should comes from top to bottom, okay. It should be very straight. It should be uniform till the end of your written in this sentence, okay. Then lettering thickness not uniform. Thickness, see, here it is started with one thickness and moving with the same thickness, and in between the thickness of the letter is reduced, right? So these kind of things you should not commit in your papers, right? Lettering space not uniform. So in between the gap for each letters you have to maintain a unique distance. You should not write just like that. You have to maintain a unique spacing. And by this we can wind up this session. I hope you understood the introduction to engineering graphics, what I have taught in this video session, and I will be posting the new videos in coming days, okay. Do listen, and in the coming videos I'll be explaining the concept in the unit wise, okay. Thank you so much.